Starting with the last term question then, it says explain, in terms of subatomic particles, what is meant by the term isotopes. So hopefully we remember that an isotope are atoms of the same element with the same number of protons and a different number of neutrons. Now, if in your answer you've said that they've got the same atomic number but a different mass number, you would not get the mark because the question asks you to explain your answer in terms of the subatomic particles. So you must refer to them having the same number of protons but a different number of neutrons. The last one's question has asked you to calculate the relative atomic mass of boron given the information about these two isotopes. So again, we need to remember the calculation for that. So we do the mass number times by the percentage. So the mass number of boron 10 is 10. And this is how it's often written to you in the exam. So we do 10 times by the percentage of 19.7 plus 11 times by the percentage of 80.3. And because it's a percentage, we're going to divide by 100, these two added together, and that gives me a relative atomic mass of 10.8. And here I can sense check my answer because it must be between 10 and 11 because those are my only two isotopes. And it's going to be closer to boron 11 because there's clearly more boron 11. Hence it's 10.8. We've then been asked to draw a dot and cross diagram for sodium chloride. I know sodium is a metal on the left of the periodic table. Chlorine is a non-metal on the right of the periodic table. And a metal and a non-metal create an ionic bond. So this is going to be an ionic dot and cross diagram. Sodium's in group 1. So it has one electron in the outer shell. So it loses one electron to gain a full outer shell and forms a +1 ion. Chlorine is in group 7. So needs an electron to get a full outer shell. So it's going to take the electron from the sodium atom. So we've got chlorine taking this electron here, this cross from sodium, and now they've got to both have a full outer shell. We then asked to draw a dot and cross diagram for hydrogen chloride. Well, I know hydrogen is a non-metal, chlorine is a non-metal, and the bond between two non-metals is covalent. So this time I'm going to draw a dot and cross bond that is covalent, so it's going to be different. I know hydrogen has got one electron in its outer shell, and it needs one electron to gain a full outer shell. So hydrogen is going to make one covalent bond. Chlorine has 7 electrons in the outer shell. It needs one, so chlorine is also going to make one covalent bond. So I need a shared pair of electrons in between these atoms, so I'm going to draw a dot and a cross in the middle of them. Hydrogen's now got 2 electrons, which just makes the first shell full, and chlorine has 8 electrons, which makes that outer shell full. So both of them are now stable. So in this lesson, we're going to look at molecular compounds. In particular, we'll be looking at the boiling point and melting point of simple molecular compounds, as well as their conductivity. So, if you remember from last lesson, we defined a covalent bond as a shared pair of electrons, and we said that exists between two non-metal atoms. Covalently bonded substances can form 2 types of structure, and we're going to look at one of them this lesson and the other one in another lesson. So today we're going to focus on simple molecular, and then in the next lesson we'll look at giant covalent. So we're going to look at simple molecular compounds, and to understand this we need to understand what is meant by a molecule. So a molecule is 2 or more atoms connected by chemical bonds. So it's a small group of atoms joined by chemical bonds. And the word molecule itself applies only to covalent compounds. So ionic compounds never form molecules, and neither do metallic compounds, which we'll come on to in a couple of lessons. So here on the board you can see 1 molecule of ammonia, NH3. Because we've got a small group of atoms held together by chemical bonds. So overall, this is 1 molecule. And I know it's a molecule because they're all non-metals, so it's covalent. So, how many atoms can we see on the board? I can count 1 nitrogen, 3 hydrogens, so there are 4 atoms in total, and these are held together by 3 covalent bonds. covalent bonds are all extremely strong, and that's really important. So these lines are my shared pair of electrons, which are really strong and take a lot of energy to overcome. But there's a really important distinction we need to make. Inside a molecule, all of the atoms are held together by strong covalent bonds. And the analogy we often give is we say inside your year group, you make strong bonds with your friendship group. So the people you spend break and lunch with every day, you've got really strong bonds that are really hard to break. Okay, that's similar with a molecule. Each atom is held together by strong covalent bonds. So on the board, you can see 3 different molecules, and we've got 12 atoms in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can see 3 covalent bonds. Between molecules, so this dashed line here, there's what we call a weak force of attraction. So you've got strong bonds inside the molecule, but between different molecules, you've got weak intermolecular forces of attraction. And intermolecular means between molecules. So only molecules will have intermolecular forces. And the only time you will include these in your answer is for simple molecular compounds. These are the only type of bonding which have weak intermolecular forces. So there's 2 really important distinctions you need to be able to make. The strong covalent bonds inside of all of the atoms, in all of the molecules holding the atoms together, and the weak intermolecular forces between different molecules attracting them together, and that's shown by my dashed line. So this is a little bit of literacy, just referring to the fact that inter means between, molecular means molecule, so intermolecular means between molecules. And again, the analogy we give is in your year group, you will have weak links between other people that you don't necessarily spend break or lunch with, but you do know. So you've got weak links with the rest of your year group and strong bonds with your close friendship group. What you now need to think about is the melting and boiling point of simple covalent compounds. And in order to answer this question, you've got to decide what type of force or bond are we breaking. So think about water. Water has the formula H2O. So we've got 2 hydrogen atoms covalently bonded to an oxygen atom. When you boil water, you are not ripping hydrogen and oxygen apart by breaking the covalent bonds. That would take too much energy. Okay, so we can never break these strong covalent bonds inside a molecule when we melt or boil them. Okay, they are too strong and would require too much energy. Think about a kettle. There's no way the kettle has enough energy to break hydrogen and oxygen apart. All we are doing when we melt and boil a simple covalent compound is we break the weak intermolecular force of attraction between molecules. So a kettle will break the attraction between the different water molecules. So the water molecules are no longer attracted, so they don't stick together, so they move further apart, and therefore they become a gas. So we're never breaking the bonds, we're just breaking the weak intermolecular forces, and it's really important you are clear of that distinction in the exam. If those intermolecular forces are weak, that means I will not need a lot of energy to break them. So the melting point and boiling point of simple molecular compounds will always be low because we are breaking weak intermolecular forces, so we don't need lots of energy to break them. We are not breaking the strong covalent bonds. For conductivity, we said the 2 things needed for a substance to be able to conduct is charge and movement. Here, we don't have any free electrons or ions. There are no ions because it's covalent, and the electrons are locked inside these covalent bonds and unable to move. So Simple molecular compounds can never conduct electricity, and your textbook explanation is because there are no free electrons or ions. That means in the exam, you need to be perfectly clear whether the bonding is ionic or covalent, because that's going to determine the answer you write for whatever question it asks you, because they've both got very different properties. So let's look at the following examples and decide if they're ionic or covalent and be able to explain why. So calcium chloride. Calcium is a metal because it's on the left of the table. Chlorine is a non-metal because it's on the right of the table. The bonding between a metal and a non-metal is ionic. Carbon dioxide. Carbon is a non-metal. It's on the right-hand side of the periodic table. Oxygen is also a non-metal because it's also on the right. The bonding between two non-metals is covalent. Potassium chloride. Potassium is a metal on the left-hand side of the periodic table. Chlorine is a non-metal on the right-hand side. A metal and a non-metal gives rise to an ionic bond. Lithium oxide. Lithium is a metal. Oxygen is a non-metal. So metal and a non-metal is ionic. If we look at water, hydrogen is a non-metal. Oxygen is a non-metal. Two non-metals gives rise to a covalent bond. Lithium bromide. Lithium's on the left, so it's a metal. Bromine's on the right, so it's a non-metal. Metal and a non-metal give rise to an ionic bond. And methane, CH4. Carbon is a non-metal, hydrogen is a non-metal, and two non-metals make covalent bonds. So this time we've got sodium chloride, a metal, sodium, a non-metal, chlorine, so it's ionic. You've then been asked to explain if it's got a high or low melting and boiling point. Explain your answer, and I've given you some words to use in your explanation. So for this, you need to state that ionic compounds such as sodium chloride have a high melting and boiling point because of the strong electrostatic force of attraction between oppositely charged ions. If you look at ammonia, nitrogen is a non-metal. Hydrogen is a non-metal, so it must be covalent. And to explain the melting and boiling point, we're going to say it has a low melting and boiling point because there are weak intermolecular forces between molecules, so not much energy is needed to overcome them. Calcium oxide. Calcium is a metal on the left. Oxygen is a non-metal on the right, so the bonding must be ionic. You've been asked to draw a dot and cross diagram, so we're going to use the outer shells only. Calcium's in group 2, 2 electrons in the outer shell, so it will lose 2 electrons to form a +2 ion. Oxygen's in group 6, 6 electrons in the outer shell, so it's going to gain 2 electrons from calcium, and we've shown that using our 2 crosses, and it'll give it a -2 charge, and these oppositely charged ions attract, which makes the bonding ionic. For the extension question, you've been asked to explain whether they can conduct when solid. Well, we know they do have charged particles, they've got ions, but in a solid, the ions are in fixed positions and therefore cannot move to carry the charge. The last little example to test your understanding of these two types of bonding is an example of a 6-mark question. So, you've been given the information about 6 substances, A, B, C, D, E, F. You've been given their melting point and their boiling point, as well as whether they can conduct or not. And you've been asked to identify which ones are simple covalent and which ones are ionic. So let's look at each one in turn. A has a high melting point and a high boiling point. So therefore, we know it's going to be ionic because of the strong electrostatic force of attraction between oppositely charged ions. It doesn't conduct when solid, and it does when liquid. And again, that confirms it's ionic. The ions are in fixed positions in a solid, so can't move to carry the charge. But when you melt it or dissolve it in water, the ions are free to move and carry the charge. So therefore, A would be ionic. B has a low melting and boiling point and can never conduct. So B must be simple molecular because it's got a low melting and boiling point because of the weak intermolecular forces between molecules, so not much energy is needed to overcome them. And it doesn't conduct electricity because there are no free electrons or ions. C is clearly a type of bond that we mightn't have looked at yet, okay, because it conducts both when solid and when liquid. So it's not ionic and it's not covalent. So we haven't looked at C yet. D has a very low melting and boiling point and never conducts. So D could be simple molecular also. So the answer for A would be B and D for this question. And ionic, we've said B could be ionic. If we look at E, it's got an extremely high melting and boiling point, but it doesn't conduct when it's a liquid. So therefore, E must be a different type of bond, and we haven't looked at yet, so it can't be E. But F has a high melting and boiling point. It doesn't conduct when it's solid, but does when it's a liquid, so F must be ionic. So it must be A and F. So you can now tell a difference between ionic and covalent. You can describe the properties of ionic compounds. You can describe the properties of covalent compounds, as well as explain them and draw your dot and cross diagrams.